Hello all. In today's session, we will be looking at AWS Security Services. Security being one of the critical factors in deciding which cloud vendor to be migrated on. AWS provides multiple key security services in order to uh, remain relevant in the market. Of course, relevant and up to date to the market. As part of today's agenda, we'll be looking at these 8 security services, namely AWS IAM, AWS KMS, AWS WAF, AWS Shield, AWS Trusted Advisor, AWS Guard Duty, AWS Inspector, and AWS Macy. So first thing first, what AWS does is it follows a shared security model where AWS offers a shared security to its consumers. That means AWS controls a few security aspects and the rest is controlled by the consumers. As per, as per this model, the consumers get to control the identity and access management aspects of the security, whereas AWS keeps the hardware and data centers available and healthy, providing all the relevant software upgrades, patches to the hard data centers available. Moving on to the next slide. First topic, IAM, Identity and Access Management. So it is a security web service offered by AWS to ensure that users get access to the resources at appropriate level of permissions. So as any application would do, it would require users in order to authenticate what all users are real and which ones are fake or bots. So in AWS we have this feature called IAM, where IAM can create users and provide them with a level of permissions and privileges in order to access any resources. So with IAM, what you can do is specify who or what can access services and resources in AWS. They can be centrally managed and fine-grained access and permissions can be provided. And next one, on this slide we have some of the benefits of IAM. Mainly it is used to set permission guardrails and fine-grained accesses. So permission guardrails stand for the boundary of permission, so the maximum amount of permission a user can have or the user can access. To the fine-grained access, to the single individual file or access that user can access. So from max to min, all the approvals, all the permissions can be set by the user by the IAM. Next we have manage workload and workforce identities across your AWS accounts. So in order to manage your workload, you can create different users and tag them to different accounts. So those users will have a relevant access and permissions to work on. Next you have is temporary security credentials and permissions to access your AWS resources. So not every time you need to punch in your uh, IAM user ID. So the users get to have temporary security credentials so they can use these credentials for day-to-day activities. Lastly, we have analyze access and validate IAM policies as you move towards least privilege. So what IAM does is it provides a least privilege principle. In that it is supposed to provide the users with the least amount of accesses or privileges that is required for their work and nothing more than that. So that is least privilege principle. One should be given only the amount of access that is critically necessary for his work and no more than that. Next, IAM comes with multi-factor authentication MFA. MFA is your second level of authentication that helps whenever you have issues with your password and credentials. So MFA is the password you know that is you are using, and a security device that you own, security app it could be, or a physical device like YubiKey that we have been using. So MFA is your second level of authentication that helps in keeping your account safe, and in this case even if your password is compromised or hacked, your account remains safe. Next we have the IAM best practices. In here I have kept some of the best practices that one should follow, not only to the IAM specific, but yeah, it should be followed at general. So what it says is don't use the root account except for AWS account setup. So in AWS you get to have a root account when you sign up for the AWS account. So what AWS recommends is you create an IAM user once you log in for the first time, and give that IAM users enough um, permissions so that all of your activities, all of your day-to-day work can be performed by that IAM user, and you don't need to use your root user on a day-to-day basis. Next we have is assign users to groups and assign permissions to the groups. So what it says is when you are creating users or adding new users, it is better to create groups and add those users in those groups, and you can apply your permissions and privileges onto the groups directly rather than adding it to each individual every time you are adding or removing the users. Next we have is create a strong password policy. So that is well known, one should have enough or good enough password and not some random 1234 in order to keep their account safe. Next we have is use and enforce the use of multi-factor authentication. So as said, multi-factor authentication keeps your account safer with a second level of permission required every time you log in. So they are trying to make it as easy as possible, but yeah, it's a second level of authentication, so it needs to have a second device that you own in order to keep your account safe. Next we have create and use roles for giving permission to AWS services. So and this is one of the good parts of AWS where uh, you don't need a real user every time in order to access some of the services. So what happens is, what if your virtual machine EC2 in this case requires some data from your databases? So you don't actually need a user every time to log into the EC2 or the databases with his credentials, take the data, put it back on EC2 for computation. So it doesn't require it all. You can have scripts that do it automatically for you, but those scripts would also require access in order to access your databases. Databases are something that is a really critical resource. So what it does is, what AWS wants is, AWS makes rules, and then the user can take up those roles in order to perform these services, to perform these activities. So users get the role, and those roles can have permissions to access a database or a storage device. So user also get those permissions when it assumes those roles. Next we have is audit permissions for your account with IAM credentials report. So yeah, we they have credentials report as well, where you can check and see whichever um, accounts you have logged in, how many times, how many days. Lastly, never share your IAM user and password. That is not something to be told. It should be inherent that you should not share your credentials with anyone. In this slide, we have IAM policy evaluation logic. So what I have tried to put it in this slide is the users have different kind of permissions. They can have different access levels, different uh, needs, different work. So how IAM policy works depends even on the resource level permissions as well. So anytime uh, there is an explicit deny or not allowed for a user, then they are not allowed for those particular services. So in this flow, if you see from left to right, whenever you have a decision to be taken and that decision starts with deny, that your particular user, this user ID is not allowed, then that particular user cannot access that resource and it has to be some other user has to be used, or it has to be given the permission. Then you can also have service control policies. So there are policies of each and every services uh, where it is allowed to have some of the users, denied to have some. So if it is allowed from the first part that it was not explicitly denied, and it is not allowed in this one, so that means it is implicitly denied here. So first one you need to have allowed, second one also you need to have allow. Moving on to the next logic, resource based. So many resources in AWS have their own set of policies. Like S3 have S3 bucket policies, your databases have their own policies in order to who can access those. And if their policies don't allow your user to access or don't allow any users to access those resources, then your user cannot access it and it fails from there. Let's assume that it passes from there as well, that resources have the policy to allow this user. Then you have identity based policies. So here you can simply see what all IAM users are allowed for this. Next one, you have IAM boundaries. So whether this particular access or this particular permission is out of your boundary, whether this user was allowed until here, but when it was found that this requires this much of permissions and this user has only some permissions, like it requires admin permissions, but this user is only allowed for a read write on a particular file or very few limited permissions. So IAM permission boundaries can deny him. Uh, if it is allowed from IAM permission boundaries, then it goes on to session policies as well. If session policies allow it, it finally gets to perform the action. So all these different logics and different workflow needs to be followed in order to reach to a particular service, access a particular service. So anywhere in this graph, if you have a deny, if you are not allowed, if you are not the user they are looking for, you won't be able to access the resource. So this is how much AWS has given security to the services and who all can use it. On this slide we have types of encryption. So this users and identity has been covered. Now what about how else we can secure our data? So whenever it comes to securing your data, one can have encrypted data or data encryption in order to keep its data irrelevant for the users who are not part of the organization or to the clients which do not have the decryption key for that particular data. Encryption here has three different types. First one is encryption in flight. Here the data is encrypted before sending and decrypted after receiving. So think about whenever you have to send your data, you have kept your data securely at your on premises. But while sending it through the internet or through the fibers, through any medium you have, there can be chances that someone can intercept those messages in between. That is called a man in the middle attack. So in this case, in encryption in flight, what it does is it encrypts the data before sending it to an open internet or even the private virtual networks, and then once it is received by the other end, there it can be decrypted in order to get the message. The other way around can be a server side encryption at rest. So in this, data is encrypted after being received by the server and data is decrypted before it is sent outside. Third one we have is client side encryption. So many times there happens that clients don't want, or they have different kind of security requirements. So the client doesn't want its data to be visually available even to the cloud providers. So they can use client side encryption where they encrypt their data, then use the services, and once the computation is completed or once the data is transferred, once the activity is done, then they again decrypt the data with their own key. As mentioned in the last slide, keys. So AWS has a service that is called key management service, which helps to give a centralized control over the cryptographic keys used to protect your data. So anytime you hear about encryption in AWS, it is most likely AWS KMS, where the keys are managed by AWS. The service is integrated with all other AWS services, and it makes it easier to encrypt data you store in these services and control access to keys that decrypt it. Also, as said earlier, never share your or never store your secrets in plain text, especially in your code. KMS have two different key types, um, symmetric and asymmetric. Symmetric ones are called AES 256 keys. Here a single encryption key is used for both encryption and decryption, and AWS services that are integrated with KMS usually use symmetric client managed keys. You never get to access your KMS keys unencrypted. Next we have asymmetric keys that are RSA and ACC key pairs. Here you have two different keys. One is public, that is helped to encrypt the data, and one is private, that is used to decrypt your data. The public key is usually downloadable, but you cannot access the private key unencrypted. Use cases for this are encryption outside of AWS by users who can't really call the KMS APIs. Next we have is AWS WAF, Web Application Firewall. So a WAF helps or protects you against common web exploits and bots that can affect availability, compromise security, and consume excessive resources. So it is a kind of a firewall. In the name itself, the firewall, it helps you with, it protects you from common web exploits. With AWS Web, you can create security rules to control your bot traffic and block common attack patterns such as SQL injections and cross-site scripting. Next, here are some of the use cases of WAF. WAF is used for filtering web traffic. You can create a filter to web requests based on the conditions, and it can filter up to 10,000s of IP addresses, headers, URLs, and in this way you can filter your traffic. Then you have prevent account takeover fraud. So a WAF monitors your application's login page for unauthorized accesses, and it helps you to see if your account is compromised before it's too late. Then you have administrator AWS WAF with APIs. So you can use or create and maintain rules automatically and incorporate them into the development and design process with the help of APIs. On this slide, we have some bullet points on how web access control list works or their rules. So IP set, it implies that more than 10,000 of IPs can be individually or in bulk set from WAF, and they can be blocked, allowed in order to control your traffic. Then you have SQL injections and cross-site scripting protection. So what is SQL injection? SQL injections are a short amount of codes in your SQL query where your data, what your data from the database is visible to the hacker or whoever has put in that SQL bot. Then we have cross-site scripting. This is the common exploit that is used by providing a URL where once you click on that URL, your data is compromised. Your account data is sent to the hacker. Next, you have a size constraints or geo match. Size constraints usually have uh, how much a size of a downloads or uploads you can perform. In order, this helps the website or application makers to keep a look for duplicate website makers or owners. It shouldn't be like someone downloads all your data and uploads it on their own web page. So by size constraints, they can uh, define a set of target that is not more than this much of data can be transferred or downloaded. You have geo match where you can block a particular country from accessing your application. Finally, you have rate based rules, so you can make rules where not more than this particular rate of access request can be given access. So if there are too many requests in a certain period of time, you can have rules to avoid them or prevent them. Next we have AWS Shield. So the last point in web rules were rate based rules. So what AWS Shield does is it provides a managed service that protects you against distributed denial of services, that is DDoS attacks, for applications running on AWS. AWS Shield standard is automatically enabled on all services, I mean all customers, with no AWS cost, with no additional cost, and AWS Shield Advance is optional paid service. So in this, what is exactly a DDoS attack? So whenever a hacker or implicit bot is trying to overload your services, overload your application, what it does is it sends fake traffic on your application and at a rate that is hard enough for you to accommodate your real users. So all your bandwidth, all your uh, uh, CPU is being consumed by these fake bots rather than serving your real customers. So that is called distributed denial of services. Some of the use cases for AWS Shield is it automatically scrub bad traffic at specific layers. So what it says is it protects your application from bad traffic as said in the DDoS attack. Then you have minimize application downtime and latency. In this way, you can manage uh, minimum downtime for your application. If you have a AWS Shield active, it can detect the DDoS attacks and then it can prevent them. Lastly, we have monitor and protect up to 1000 resource types. So AWS Shield once activated, it automatically detects mitigation or protection for each resource type per AWS account. Okay, here are the two types of AWS Shield. First is Standard. Shield Standard is a free service that is activated for every AWS customer. It provides you protection from UDP, SVN flood attacks, reflection attacks, and other layer 3, layer 4 attacks. What AWS Shield Advanced gives is it provides optional DDoS mitigation service. It has a cost related and it is as per last documentation it was $3,000 per month per organization. Then you have protection, more protection against sophisticated attacks on your EC2 load balancers, CloudFront, Global Accelerator, and Route 53. You have a team dedicatedly supported 24/7 access to DDoS response team, DRP team. Then you have protection against the surge that was caused during the DDoS attack. So Shield Advanced protect you against higher fees during usage spikes due to the DDoS. Lastly, you have Shield Advanced Automatic Application Layer DDoS Mitigation that creates, evaluates, and deploys AWS Web rules to mitigate Layer 7 attacks. Next, we have is AWS Trusted Advisor. So, what Trusted Advisor does is it helps you optimize cost, increase performance, improve security, resilience, and operate at large scale. So, Trusted Advisor runs or evaluates your account, your resources with best community or best AWS practices, and then provides you with reports where you can save your cost, improve your performance, like that. So it also comes with two different versions. The other one is Trusted Advisor Priority that helps enterprise support customers focus on most important recommendations by providing both the context driven and prioritized recommendations from AWS account team. So there is an AWS account team uh, ready for support if you need in trusted priority advisor. Here are a few of the trusted advisor use cases. It says optimize cost and efficiency. So here what it does is when it runs or evaluates your resources, it finds out the unused resources and it can provide you with opportunities to lower your cost. Next is address security gaps. So all these address security gaps, improve performance, improve resilience, all these are found and all these are analyzed during evaluation only. So when it evaluates your resources against the best practices of AWS, it can help you with all these issues. Lastly, we have this track service limits. So in here it checks the usage for your account and gets notifications when your account approaches or exceeds your service limits. So in AWS you can set up service limits so that you don't get billed more than what is your expectation. So this AWS Trusted Advisor sends you notifications whenever you are about to breach or whenever you are about to cross the service limits. Next we have Amazon Guard Duty. Amazon Guard Duty combines machine learning and integrated threat intelligence from AWS and third party to help protect your AWS accounts, workloads, and data. So here you get ML and intelligence in AWS as well. Benefits of Guard Duty: continuous monitoring. It keeps your accounts, workloads, and data secure by continuously monitoring for potential threats across your AWS environment. ML power threat detection, respond faster to threats. AI can help you detect uh, threats before they are actually happening, or at the time with the least uh, difference in order to respond faster to the threats. It can accurately detect and respond to threats, so that can help you before the issue escalates. Lastly, you have end-to-end visibility into AWS compute workloads. So here you have safeguards for your account, data, and resources across various AWS compute types. So a guard duty takes care of all your services end to end. This one is your Amazon Inspector. Uh, Amazon Inspector automatically discovers workloads such as EC2, Lambda, and ECS. So you can say it is more of a specialized threat detection tool for these three services. It scans your services for software vulnerabilities. So anything, any issue with the software or any unintended network exposure, you can get to know with Amazon Inspector. Amazon Inspector has various benefits and some of them are listed below. One of them is detect software vulnerabilities. It can detect the vulnerabilities and intended network exposure in AWS workloads. Next we have manage SBOM exports centrally. So what Amazon Inspector does is it can incorporate security earlier in the development cycles and centrally managed software bill of materials, SBOM exports for all your monitor resources. So you can get uh, export for all your resources. Thirdly, you have prioritize remediation. So use Amazon Inspector uh, risk score. It provides you risk scores to remediate your resources, to reprioritize your remediation. Lastly, maximize vulnerability assessment coverage. Here you can seamlessly scan EC2 instances, switching between agentless and agent based scanning. Lastly, we have this Amazon Macy. Amazon Messi is a fully managed data security and data privacy service that uses machine learning and pattern matching to discover and protect your sensitive data in AWS. Messi helps identify and alert your sensitive data such as personally identifiable information. So what happens is at times you have some personal data that is stored on the cloud. So AWS needs to know, or your client needs to know, whatever personal data you have with the cloud is not shared otherwise. So AWS Messi or Amazon Messi can find those personal identifiable information using machine learning, and that can be worked upon. That was last of the security services we were discussing, and we'll be back with more. Thank you.